All right, so hopefully you actually worked through the activity. If not, so be it. But one thing that I do want to point out on this applet, if you click this box right here where it says show the mean X and Y lines, what that's going to do is it's going to show a line for where the average X is. So like if X bar is about right here, it's going to show the line for that. And then it's also going to show the line for Y bar, the average of all the Y values. And what you would notice if we were doing this in class, I would have everybody click on that, and you would all notice that X bar and Y bar are on everybody's line. So just something to know is that the LSRL always contains or goes through the point X bar, Y bar. It's what's called the balance point. And so every LSRL will always have the point X bar, Y bar on the line. All right, so as you went through this, you'll notice that we had our points up here. I'm gonna take that off for now. In my original one, it looks like these. And then we have these points that we're adding in, A and B, and then C and D. And so what I want you to notice is that A and B are both outliers horizontally. They're out to the right or to the left, on the right end of the data or the left end. Where C and D are what we would call more vertical outliers. They have really large residuals. A and B have large residuals also, but A and B and C and D are going to change our slope. If you work the activity, you would see that it changed the slope, it changed the the correlation, and it changed the y-intercept. So adding point A and B both decrease the slope because these 2 points cause the line to tilt. And we'll look at an example of that in class next time, but both of these cause the line to tilt. So if I put A in there, it's going to make my new line look something like this. Okay, and B is going to do the same thing. It's going to cause the line to tilt, right? And so when it does that, the slope decreases because we had a positive slope and now it's not quite so steep. The y-intercept increases because as the line tilts, that left end comes up. And then of course the correlation does go down. The correlation is not as strong. When you add points C and D, they affect the slope a little bit, but not quite as much. So when you added these, hopefully you saw that the slope pretty much stayed the same. The y-intercept decreased on C and increased with D, and for both of them got weaker. But what C and D do here is they actually just kind of cause the line to shift up or shift down. So those types of vertical outliers cause the line. This one tilts the line, and this one causes the line to shift up or down. Okay. All right. So the question 3 says, why are points A, B, C, and D considered outliers? The main reason here is that they don't follow the overall linear trend. They are outside the general pattern, and they also have large residuals. Okay, don't follow the overall linear trend. Okay. Then if you go back and look and it asks which outliers had the greatest impact on the LSRL, vertical or horizontal outliers, what we discovered was that the horizontal outliers had the greatest impact. They made the most change. So these are what we call high leverage points. Okay. All of these are influential points. And so an influential point is a point that if you remove it, it substantially changes the slope the y-intercept and or correlation. So it can change all three, it can just change one of them, it can change a couple of them, but outliers and influential points will often change the correlation substantially. Sometimes it makes it stronger, sometimes it makes it weaker. We saw earlier that if we add an influential point that's in the pattern, it can increase that correlation significantly, even though it would not be an outlier. All right, so let's do some summary quick notes here, okay? Outliers are any point that's out of the pattern. Usually has a large residual. A high leverage point has a very large or very small X value. And then influential points, if removed, big changes to slope, y-intercept, and r. Okay. Learning target 2. Well, actually, this is learning target number 1. So let's talk about outliers and the LSRL. Okay, so horizontal outliers those are going to tilt the line. Vertical outliers, those are going to shift the line up and down. Okay. And then learning target 2, we haven't looked at this yet. This is using the formulas for LSRL. So formulas to calculate the LSRL, these are formulas that will be given to you on the AP sheet. So it's y hat equals a plus bx. And these are formulas that allow you to find b and allow you to find a. The formulas that you'll be given is it'll say b equals r times s sub y over s sub x. And y bar, the average of the y's, is equal to a plus bx. So for that one, you will have to resolve it to get a. So a equals y bar minus b times x. So you find this one first and you use this one second. When you are asked to use these formulas, you will be given everything that's highlighted. So you'll be given r, you'll be given the standard deviation of y's, the standard deviation of x's, and you will be given, sorry, this should have an x bar on it. You will be given x bar and y bar. And your job is just to figure out what B and A are. All right. Go ahead and work through the check your understanding, and we will go over that in class on Thursday.